Okay, so this is an illustration of a human body to try and demonstrate what we do in a syncope ablation. So this is the body. We're going to get rid of the outer layer to show the skeleton. And then we're going to get rid of the skeleton just to show the nervous system and the heart and how it relates to the heart. So the first thing to note is that there are two major nerves here. Here I've highlighted the vagus nerve, which is running alongside one of the major veins in your neck, the internal jugular vein, as you can see here, which is this blue structure. And if I just click on the vagus nerve on the left-hand side of the neck again, let's follow its course down. And if we follow the course down to where it sits on the heart, it tends to kind of move into the section of the heart and sends out branches. So that is the beating heart. These are the atrial plexi, which I'm going to highlight, which are branches of the vagus nerve here. So if I can pick on that atrial plexi in pink now, what you can see is that the heart is modulated by nervous tissue inputs called the autonomic nerve system, and they're both sympathetic and vagal fibers. And the fibers that we're very interested in trying to tackle or ablate in a cardioneural ablation procedure are these branches of the vagus nerve. And you can see how they innervate the heart. And if you like, a high vagal nerve expression will start to slow the heart down and even stop the heart. And that is why an ablation procedure here to tackle the nerve fibers and destroy them can actually stop the slowing of the heart. So we wrote this article, which you can download for free on the link below, which we'll try and add to the description on the channel. But essentially it highlights what we've already discussed, that there are two vagus nerves that come down here and innervate the heart. And the point that I want to make right now is that as these vagus nerves come and distribute or ramify into the heart, they collect in areas called ganglionated plexi all around the heart here. And these ganglionated plexi specifically can innervate regions within the heart. So for example, this particular ganglionated plexi, which innervates specifically the sinus node or sinoatrial node, can lead to a condition called sinus arrest. Now, sinus arrest is when your natural pacemaker just stops. So if you think about your electrical impulses always originating from this sinoatrial node, SAN, and then moving over towards the AV node before conducting into the ventricles, giving you a P, which is this wave, which is the sinus contraction, and then the QRS complex, which is the ventricular contraction, which is this chamber here. What we can see is a sinus contraction P wave QRS, a sinus contraction P wave QRS, and then no P wave. You would have expected the next one to arrive there, the next one to arrive there, but no P wave at all until this point. And this pause of under 3 seconds is what is called a sinus arrest. And this sinus arrest is said to be due to a lot of innervation or activity within the vagus nerve in this region that innervates the sinus node. Now, if we take it further to talk about the AV node, which is this ganglionated plexi, a different ganglionated plexi that sends its fibers into the AV node. Now, this is responsible for linking up the P and QRS contraction. So in other words, the electricity needs to flow from the atrial chambers downwards via the AV node into the ventricles. And so this interval here is what we say is a sinus P wave, an AV interval or PR interval, and then a QRS complex. And you can see here what happens is that the sinus node works just fine. This is a P wave, but where you might have expected the QRS to come in here, there is what's called AV block. And this AV block is a signature of in the case of our patients with vagally mediated AV block due to vagal expression of a lot of impulses coming from the vagus nerve on either side and innervating this GP. So in the case of our example patient, this is the actual data taken from his recording, And what you can see is he does have mainly AV block, but sinus slowing. So he does have a P wave here and here, but these are slow P waves followed by sinus beats here, 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 and here. So this is AV block, leading to a complete heart pause of 4.7 seconds.